I'm going to talk about how we used Temporal to build some data pipelines to create what we call account summaries utilizing generative AI. So a little bit about me. I'm Frank. I'm a senior principal engineer at ZoomInfo, and I'm based in Portland, Oregon. I've been at ZoomInfo for around 8.5 years, and I'm an architect on our applications team. So what we're going to talk about today, we're going to do a little intro of ZoomInfo, if you're not familiar with what ZoomInfo does, and talk about the Copilot product a little bit. Then we'll dive into some of the technical details for the workflows that power the Account AI feature, which is part of Copilot, and then go into some of the considerations we had to make when working with the large language models for this project, and finally share a few next steps that we see with this project. So if you're unfamiliar with ZoomInfo, which if you're not in the sales space, you probably are, ZoomInfo is a B2B sales and marketing data intelligence platform. Typically, users of ZoomInfo will come into our platform and utilize our extensive search functionality to search our large database of professional contact and company data to identify new customers and contacts at those customers. So ZoomInfo Copilot, which we launched earlier this year, is a shift in paradigm to a signals-based selling approach. So rather than sellers having to search blindly through the 400 million contact and company records, ZoomInfo takes signals from many different data sources, combines those together, and tries to predict who your next best company or next best customers are going to be. And so these signals can come from various data sources. They can be visits to important pages on your website, like a pricing page or a free trial sign up, signals from third-party data sources like G2 and TrustRadius, new decision makers being hired, or companies receiving new rounds of funding, and many more. And so it uses generative AI to combine those signals and identify who are the most likely next accounts in your market, who at those companies you should be talking to, and helps you to know exactly what to say when you reach out to those companies. And so Account AI is a feature that was launched as part of Copilot, and this helps you to easily research your accounts and understand what to say when you want to reach out to those. And so let's say, for an example, you are a seller for an observability product, and you think that Temporal would be a really good customer for you. So there may have been already some engagements with Temporal, some meetings, maybe a demo was already booked. And so what Account AI does is it gathers all of that information so that sellers no longer just spend minutes to hours doing research and reading old email threads, going through their CRM, checking what meetings have already occurred. You can just come into Account AI and you get that single clear view of where you are with this account. And then there's two main features here of Account AI. We have what we call the account summaries. These are the documents on the left side here. This is all of that information summarized, put into a single place. And then you have the account chat, or Copilot chat as we call it. And this allows you to kind of easily extract key information from those account summaries utilizing GenAI. So account summaries really serve as the primary context for that Copilot chat. And so we first had to identify what are the different data sources that we want to pull into account summaries. And so the first thing is something we call account briefs. It's a bit of a confusing name. It's more of an internal name, not something that's really appears in the summary itself. But this is the ZoomInfo data summarized. And so this is technographic data, firmographic data, something we call intent signals, which is a way to measure whether certain companies are viewing web pages tied to specific keywords over an established baseline. And then we also have earnings call summaries for publicly traded companies. We then pull in your engagement data. This is emails, calendar events, meeting recording summaries. This helps us to figure out what you've already talked about with this customer, and as well identify important or frequently engaged contacts. Next, we have CRM opportunities. This is basically any open opportunity from your CRM is pulled into the account summary. And then finally, any tenant-specific ZoomInfo data. So a big example here is what we call contacts in your buying committee. So a buying committee is a set of criteria that identifies who are the typical people at a company that you're going to be talking to sell your product. So you can set criteria based on departments, job title, and management level. And so the account summary will pull in those key contacts with additional information into the account summaries. So now that we have all of the data points that we wanted to pull into these account summaries, we had to figure out how do we build these account summaries. And since these summaries are probably the most important feature of the account AI, we wanted to ensure that the process for building these account summaries was as stable and as durable as possible, because this process runs continuously as there's new data always coming in, and so we want to make sure that these account summaries are always as up to date as possible for our customers. And so we came up with an initial workflow design that was pretty simple, where we fetch at a list of accounts that we want to build these summaries for. We then start a process for each account, fetching all of the data for that account, building the account summary, and then we store, this is all running as a background process, so we can store the account summary for easy retrieval and quick retrieval for in-time user applications. After we kind of started developing against that initial workflow design, we ran into some initial challenges. So we are heavily utilizing LLMs in this, so we really needed to optimize our workflows around isolating around the stability and performance implications with LLMs. So there are tight rate limits, the latency is generally pretty high, and they're still not the most reliable, so there's a lot of intermittent failures. And then as well, trying to control costs with the LLM, we want to ensure that we're only reprocessing the data every day that is absolutely necessary. The next issue was the account briefs. So as I mentioned, I think I mentioned, this was an existing product, and it's managed by an external team. And they also rely on LLM for summarization of ZoomInfo data. And so we had to build our workflow to match what they did, which is they actually implemented a batching model to handle the throughput limitations. And so they could accept a batch of up to 1,000 accounts per batch, and a single batch at a time. And so we had to design our workflow around that methodology. And also, account briefs are the only data point in these account summaries that are not based on tenant-specific information. And so to, once again, optimize around that, we wanted to reuse account summaries and not duplicate generation of account summaries if we didn't have to. So for the entire 30-day life cycle of an account brief, we want to use that if many customers are requesting an account summary be built using that same account brief. And finally, we wanted to build our workflows such that they're easily extensible. So it's a small amount of work to add new data sources. Customers can configure their account summaries very easily, and we can adapt to different generation cadences per customer. So understanding all of those initial challenges, we kind of rethought our initial design, and we broke it down into 3 main workflows. So we have the account orchestrator workflow. This is a single long-running workflow per customer that's enabled for the entire lifetime of while they have the account AI feature enabled. By its name, it kind of orchestrates the entire process, the regeneration cadence, and handles any signals coming from the customer to maybe force regenerate a specific profile or any changes in their configurations. We also moved the data fetching to this workflow, as that really helped us to identify the specific profiles that have new data each day, and that informs kind of the processes later on. The next is the account brief workflow. So as I mentioned, the team that manages that service implemented it using a batching model. And so the way that we found to handle that with many customers trying to generate the same brief at the same time was we created a single workflow, and not only that, a single workflow execution that runs all of the account brief generation. And then through the use of signals, we can have many customers signal into that workflow, and that workflow can signal back out to the customers when execution is done. And then finally, we have the summary generator. So this workflow is probably the most executed workflow in our system. This runs per account, per customer. And so this is what actually talks to the LLM and builds that account summary document at the end of the process. And so, because we can potentially be running 20 to 30,000 executions of this per customer per day, we wanted to limit as much as possible the executions of this workflow. So now we're going to do kind of a deep dive into each of these workflows separately. So first we have the account orchestrator workflow. So you'll see here, the general flow is we fetch this account list. I've kind of mentioned this concept of an account list a couple of times. So ZoomInfo, once again, has a huge database. We have about 90 million company records, and so it's not practical for us to generate account summaries for all 90 million companies for every customer. And so what we do is we give them the opportunity to create a set of criteria. This is usually based on CRM filters. And that makes this list dynamic. So as new companies are added to your CRM, or as they maybe change state within your CRM, then as soon as they match the criteria to generate an account summary, the next run, they'll be pulled in, and an account summary will be generated for them. So once we have that account list, we run into our data fetchers. As I mentioned, we pulled these up to easily identify which profiles have new data. These are generally run by, we kind of watermark for each profile when the last time we fetched data for it. We fetch the new delta of data, and then identify which profiles have new data. There is some additional logic here because specifically CRM data, customers will often run processes in their CRM that update almost every opportunity. And so we want to avoid reacting to data changes on opportunities that are not on fields that are important to the account summary. And then the account brief data fetcher, this is where we determine which accounts have an account brief that needs to be generated, which accounts have an account brief that is expired and needs to be regenerated. And after all of that, we bring this together, and then we can start the account summary generation process. So looking at the kind of a high-level view of the code for this, we first start with fetching that account list, and then we pass those accounts to all of our data fetchers. We run all of our data fetchers in parallel, and then we run them as child workflows, just because there's multiple steps there with the data fetching, the additional filtering, the re-watermarking of each profile, and we wanted to add the durability of temporal to each of those steps rather than running it all as a single activity. Once we have all of the responses from those data fetchers, we can join all of that together to get a unique list of the accounts that we want to process for that day. And then we extract the accounts that need a new brief or need a brief regenerated. And then we also create this change data map. And so this helps us to know later on in the process which points of data for this specific profile have actually changed, and that can help us to, once again, optimize and only regenerate sections that actually need it. So for accounts that don't require any brief generation, we can go ahead and start the generation process for those. For accounts that do need a new brief to be generated, what we do is we signal to the account brief workflow, and the way that the account brief workflow is built, we're not sure whether it's ever running, because if there's no data to process, it's going to complete its execution. And so Temporal makes that very easy using signal with start. And then once we signal to that workflow, we then create our own signal handler waiting for signals back from the account brief workflow. When we get a batch back, we can remove that batch from the list of accounts that we're waiting for, start the summary generation process, and then continue the cycle until we've processed all of those accounts. So now the account brief workflow, as I mentioned, this is a single workflow execution. It can take signals from as many customers are currently running their process at a time. It then persists those signals into a database that maps, okay, for profile A, workflow 1, 2, and 3 are waiting for it, and profile B, only workflow 2 is waiting for this brief to be generated. So once we persist that mapping, we can then fetch the next batch of data, process it, and then using that mapping, we signal back to those workflows that are waiting on which specific profile. Finally, at the end of the process, we just check, hey, is there any more data to run? If so, we start the next batch through a continuous new, and otherwise, this workflow will complete its execution and wait for the next customer to start running. So looking at the code here as well, we start with the signal handler. It's fairly simple. We just take the signal input, we store it into a temp variable, and then you'll see the next step is that persistence step. So this persists any new signal requests into the database, and then that can inform when we fetch the next batch, process it, and then signal back to the waiting workflows. You'll see at the bottom of this process, we also have another call to persist new signal requests. And so that's because if we have a lot of customers running during the batching process, we're continuing to get signals. And we notice that sometimes we receive so many signals that if we just passed all of that through back to the continuous new, the payload body would be too large. And since we anyways have to persist those for the mapping and batching anyways, it was easy to just kind of replicate that process at the end of the workflow, and that keeps our continuous new payload manageable. The final workflow is our account summary generator. As I mentioned, this workflow, it's pretty simple, but we have potentially 20,000, 30,000 of these running per customer every day. And so one of the big things we want to call out here is the kind of isolating activities that are hitting the LLM and activities that are not. So if you've worked with an LLM, you know that they have pretty strict rate limiting. As I mentioned, the latency is kind of higher, and so Temporal makes it really easy to isolate those parts of your infrastructure. So all we had to do was create a new worker with a new task queue, and we can set the parallelism on that task queue to a lower volume, and that prevents us from overloading the LLM. And with all of these activities running on this specific task queue, if there's a lot of retries, then they're not really getting in the way of any other execution throughout the system. And then, in your workflow, you just have to make sure that you register your activities. As you can see, we're using TypeScript, but you just register your activities to that proper task queue, and Temporal takes care of all of this for you. So, what probably could have been a fairly substantial project to handle these special throughput limitations and everything is managed in about 10 lines of code with Temporal, so it's really powerful. So the account summary generator workflow, some things to talk about here. We first fetch what we call the sections of the account summary. So these are stored into a database, one, to make it easier to add new sections, and two, because customers can configure whether they want certain sections enabled or disabled. And I'll come back to the next line where we're doing some email thread summarization. I'll get to why we're doing that. But then after all that happens, then we run our section builders. And so some of these section builders have to talk with the LLM, some of them not. And so that, it makes it easy that it basically all looks the same, and Temporal manages assigning it to the right task queue behind the scenes. And these section builders use that change data map that we created back in the Orchestrator, along with the section config, which knows which data points inform the data for that section. And so if there's no new data that informs that section, we know we can just reuse the previous value that was generated the day before. And if there is new data, then we regenerate it and store the new data for later. And then at the end of the process, we have a single activity that pulls all of that data from the various data sources that the section builders stored it and generates the full account summary. So with this project, we are working with potentially very large volumes of data passing to the LLM, specifically with the engagement data. So we have emails, meeting recording summaries, calendar events, and the biggest thing really is emails, where this is not just an email between myself and a seller. This is anyone at my company to anyone at a particular company, and so there can potentially be thousands of emails. And so we really needed to optimize what data we're sending to the LLM. And so one of the ways we did that is limiting anything that doesn't actually provide context to what we're trying to find. So out of office messages, automated replies, we filter those emails out. And then we also try to limit any data duplication as much as possible, and I'll talk about that here in a second too. Data fidelity. With the large volumes of data, we have to make some sacrifices to the data that we're sending in, and so we want to make sacrifices to that data, keeping in mind keeping the response fidelity from the LLM as high as possible. And then finally, with our prompt engineering, LLMs can kind of get a little bit wordy talking about how they decided to come up with the answer that they did, and so we needed to engineer our prompts in a way that we could extract just the section of data that is really important for us to then store into the account summary without any human interaction. So as I mentioned, emails are kind of our biggest data source and our biggest challenge. And so one of the ways that we mitigated that was we found that if we sent all of the email bodies along with all the other engagement data we had, we were running into, at least at the time, we were running into hitting the limits of the input context that LLMs could understand. And so what we decided to do was to take each email, sort it into its threads, and then summarize each thread and use those thread summaries as the input for the emails rather than the raw email bodies themselves. And so this led to even more optimizations that we had to do. So rather than summarizing every email thread every day, we kind of took all the emails, grouped them into threads, extracted some sort of identifier for each email, and then we hashed all those together. And then we could use that to check what was the hash from yesterday, and that way we know, okay, there's been no new email content added to this thread, so we don't have to re-summarize it. We can reuse that summary. And so that keeps us, the initial process is large. We have to summarize every email thread, but from then on, we're only summarizing maybe 10 to 15 threads a day or something like that. For actually sending the data to the LLM, we kind of replicated what if you did a printout of an email thread, what that looks like. LLMs are very good at parsing that. And we used an XML-like structure to kind of delineate each email within the thread. And finally, going back to the limiting data duplication. So we have additional data for each of the participants in an email thread. Pulling from the ZoomInfo data, we have their name, we have their job title, we have the full company name. And rather than including that directly in the email body, where if this is a thread with 50 emails and 15 people on it, that data is duplicated now hundreds of times and driving up the cost of the LLM with your input tokens. So what we found is we could create a separate section in our input context, and the LLM was really good about mapping from the emails and the email addresses in the email body to the email addresses in the participant section to make that context association. So with all of that, we were able to build these account summaries. And we originally had a thought of only running about a beta of around 200 customers for the first year. And with the success of this product, we already have over 300 customers running on the account summaries. And so, some next steps that we have for this project are we're always looking to improve our LLM performance and quality. We're constantly tweaking our prompts to try and get better responses from the LLM. And as you know, LLMs are constantly increasing the size of the context that they can handle. So now, as that increases, we could potentially use all of that raw email data versus having to summarize each email thread first. We're also looking at utilizing prompt caching. This is kind of a new methodology that's been recently released for LLMs. And a lot of our sections utilize a similar context. And so I think we can find that using prompt caching would either, one, allow us to use that larger input context without raising our costs too much, or we can utilize more advanced models without raising our costs too much. So there's a couple of options that we can utilize, that we can go with utilizing prompt caching. We are constantly looking at how we improve our temporal usage as well. This was the first project that we released on Temporal Cloud at ZoomInfo. We have some other projects, but they're still running on our self-hosted cluster. And so, with the account summary generator workflows running potentially 20,000 at a time per customer, our usage is fairly spiky. And so we're finding it hard to establish a good actions per second rate limit for our namespace. So we're looking at ways to kind of like spread out the usage of this process and allow us to create a cleaner baseline for those action per second. And then finally, we're always looking to add more data to the account summaries, more data providers, and we want to allow our customers even greater customization. So one of the new features that we're kind of coming up with is to allow customers to customize the prompts that inform each section, so they can really tailor, the prompt to generate answers that are important for them versus kind of a standard system prompt. Obviously there's challenges there. We have to make sure that they're not, putting in any malicious information or whatever. But I think that's going to be a real game changer for customers to be able to customize their prompts and really begin to personalize these account summaries. So that's all that I had. Thank you. Do we have time for questions? That's what, I can probably repeat it and then.
The biggest question is, when you're trying to summarize or create these account rates using LLM, how do you ensure they're accurate? Because LLMs can tend to hallucinate, right? You don't want that. So how did you account for that?
So yeah, the question for those who couldn't hear is, how do we ensure that the data that we're getting from the LLM is accurate? There's no easy answer to that, but what we do is we have a big data platform at ZoomInfo, and so basically every response that we get from the LLM, we push into that data platform, and then we have a team of analysts that can analyze that data and try to discern, okay, we've been getting some weird answers on this section, so maybe we need to retweak the prompt there. Yeah, so I mean, I think the biggest thing that helps us with temporal is, if in the case of we have too many input tokens, that's something that we need to go back and fix ourselves. That's not going to be fixed just by retries. But I would say that the kind of inconsistency of LLMs is one of the biggest reasons why I wanted to use Temporal, because it's so easy to just say, all right, on this activity, you have 4 retries, you have initial back off of this, you have the back off coefficient. All of that makes it super easy to just say, okay, Anthropic's down right now, and so these activities are basically just going to continue to wait, and they'll back off with their retries until eventually hopefully Anthropic is back up. And because Temporal is built, and because we're using Temporal in the way that we are, if a specific profile fails one day, we still have the profile from yesterday. It doesn't have the most up-to-date data, but we're constantly running this over and over again. So that durable execution of continuing to run through this every day, we can then, if a section of profiles fail, the next day, hopefully they will come back around and and regenerate, and there's no real interruption to our users at all.
Do you build any monitoring tracking system around to monitor these activities?
Yes, so we use Datadog. We have
Can you repeat the question?
Oh, so he was asking if we have any monitoring around failures with the LLM, and so we have Datadog, and basically mostly used by logging. So we can track any failures and log those messages to Datadog, and we can create alerts that tell us whether we're having a lot of failures on specific profiles or for a specific customer.
Last question. It's like when you're dealing with a lot of emails,
Mm-hmm.
and the emails can have like embedded XML, HTML, and even images. So what do you do about things like that?
Yeah, so he asked about emails can have embedded, basically attachments with the emails or embedded XML. Anything embedded directly in the email, we're processing. We're still working on adding email attachments as processing for the account summaries. But yeah, we capture as much data as possible. But yeah, right now we're not doing anything with email attachments. Sure.
How was your decision-making process between self-hosted Temporal versus Temporal Cloud?
So that was, how was the decision process between self-hosted Temporal and Temporal Cloud? I will say that I think it was a pretty easy decision for Temporal Cloud. Our self-hosted cluster is relatively small. We run a few workloads on that, but generally I'm guessing that those workloads are generating maybe maybe like 2 to 3 million actions per month or so. This project, our production, with just 300 customers, the production namespace is generating about 200 million actions per month. So the scale made it really easy to pick Temporal Cloud for this.
Okay, thanks so much, Frank.